Welcome back, mini mathematicians. We're going to be filling in our lesson purpose for 4.3D. Your guest teacher will be passing out the paper copy. You'll also want a calculator. So we're going to pause the video for 3 minutes to write down the lesson purpose in our notebook and have a calculator. Thank you. Okay, so taking a look at 4.3D, our lesson purpose is to be able to translate words into inequalities, so thinking about what is maximum, minimum, at most, at least mean for inequality symbols, define our unknowns, meaning defining our variables, and solve what we write, our inequality write, and then answer in context. So let's take a look at our lesson. Mine's not pink, so it shows up better on the screen. 4.3D lesson, write and solve inequalities for word problems. So we're going to read the first word problem. Follow along as I'm reading to you. A 150-pound person burns 6 calories per minute when walking at a speed of 3.5 miles per hour. While walking, this person eats a treat that has 40 calories. This treat subtracts from the calories burned while walking. So let's look at what the question is. How long must a person walk at this speed to burn at least 190 calories? So let's think about our unknown, x. Let's call it x. Let x equals, and we're asking about how long must a person walk. So is that a distance or a time? Well, if I go back here, it says per minute, 6 calories per minute, so underline that. So we must be talking about time. Time in what? Time in, that's right, minutes. So x is time in minutes we spent walking. And it's really important to do a really good job at defining your variable. So let's go back to the word problem and find out more information. So this 150-pound person, I don't think that's going to be important. I think it's just extra information for us. Burns 6 calories per minute. So if we're burning, are we gaining or losing? Oh, we're losing. Walking at a speed of 3.5 miles per hour while walking, this person eats a treat that has 40 calories. How long must a person walk at this speed to burn at least 190 calories? Well, I don't think 3.5 miles per hour is important, or 150. So let's see, 6 calories per minute. Well, if we walk for x minutes and we're burning 6 calories per minute, that means we burn 6x calories. Okay, well, but we're also eating a treat. So does that mean we burn more calories or less? We're saying it subtracts from the calories burned, so that means we're burning not as many. And we're comparing this to 190 because we want to burn at least 190. So could that be equal to 190? Yes. Could it be more than 190? Yes. Could it be less than 190? No. So we know that this amount here, 6x minus 40, has to be greater than or equal to 190. Awesome. Let's get to solving our inequality. First thing we need to do is isolate our variable. So we need to add 40 to both sides. When I do that, I end up with 6x is greater than or equal to 230. I need to get x by itself, so I'm going to multiply both sides by 1/6 or divide both sides by 6. Oh, do I need to flip my inequality symbol? Nope, we're not multiplying or dividing by a negative. So we'd end up with x is greater than or equal to 230 over 6, which we wouldn't really talk about that much as a human. We would communicate it as 6 goes into 230 38 times with a third left over. So what does this mean? We need to interpret this answer. How long must a person walk? And we had x as time in minutes. So this person must walk. Is it exactly 38 1/3 minutes? More than 38 1/3 minutes? Well, x has to be greater than or equal to, so this is the least because it says at least. Must walk at least 38 1/3 minutes to reach the goal. So there's our answer. So we'll give it a little circle. What will happen if the person walks for a longer period of time or a shorter period of time? Well, if it's longer, they're gonna burn more calories. Or over 190. If it's a shorter period of time, they're gonna burn less calories or less than 190. Cool. Let's take a look at 2 through 8. The directions are really important, so please follow along with me. Define the variable, write and solve an inequality, write your answer in complete sentence in the given context. So there's a lot of things they want us to do. They want us to define the variable, write, and then solve an inequality, and then write your answer in a sentence in context. So that means don't forget your units, and make sure you're answering the question in the correct wording. So it's not always going to be equals or is. It might have at least or at most or up to. And let's look at number 2. Please follow along with me as we read the problem the first time. Andy has $550 in a savings account at the beginning of the summer. He wants to have at least $200 in the account by the end of the summer. He withdraws $25 each week for food, clothes, and movie tickets. How many weeks will his money last? Well, let's take a look. We're starting with $550. That's important. Let's underline it. We want to have at least 200. So could we have exactly 200? Yes. Could we have less than 200? No. Could we have more than 200? Yeah, that's fine. In the account by the end of summer, he withdraws $25 each week for food, clothes, and movie tickets. Not helping us saving here. How many weeks will the money last? After we read the problem at least twice and underline important information, we're going to go back and we're going to need to define our variable. Our variable is what we're asked about or our unknown. So let x equal how many weeks? Number of weeks saves money. Perfect. So how much money did we start with? We started with $550. I guess instead of saves money, we can say spends money because that's what he's doing. He's spending it. Then we are spending money. How much are we spending each week? $25 each week. And how many weeks are we spending or saving money for? X weeks. So should we add or subtract? We should subtract because it's money that's going away. How much should we subtract? Well, if it was 1 week, it'd be $25. If it was 2 weeks, it'd be $50. If it was 3 weeks, it'd be $75. But this is X weeks, so it's 25 times X. And we're comparing that to $200. We want to have at least $200. So this amount here, whatever number we get, could be equal to $200 because at least $200 is at least $200. Could this amount be less than? No. Could this amount be greater than? Yes. So we have this wonderful inequality that we're going to go ahead and solve. First step is we need to isolate our variable. So what should we do to both sides? That's right, subtract $550. You can go ahead and use your calculator if you want to. From here, we have negative 25x is greater than or equal to, well, 200 minus 550 is going to be negative 350. And then we still need to get x by itself. I'm going to divide both sides by a negative 25. Wait, what are you doing? Dividing both sides by a negative, you say? Don't forget to circle your inequality symbol so you don't forget to flip your symbol. Negative by negative is a positive, so we have x flip your inequality symbol, is less than or equal to, and what's 350 divided by 25? Well, 25 goes into 100 4 times, and we have 350. So that's 3 groups of 4 and then an extra 2, which gets you 14. So let's interpret what this means. How many weeks will his money last so that we have at least $200 at the end? The money will last, let's think, it'll last 14 weeks, but it will also last less than 14 weeks. Will it last more than 14 weeks? No. So the money will last at most or up to 14 weeks. Great job. Excellent job. Let's move on to number 3. Okay, let's read number 3 together. On vacation, Caitlin wanted to have her hair braided in multiple braids to cover her head. The beautician charges a flat rate of $4. That's important, flat rate of $4, plus 75 cents per braid. Underline that. She saved $29 to get braids. How many braids can she get? Okay, so step 1, we read the word problem. We underlined the important information. I squiggled the question. Let's think about defining our variable. What's x, our unknown, represent here? We're asking how many braids can she get, so x equals number of braids Caitlin gets. Okay, so let's take a look. She saved $29 to get braids. So this is going to be talking about how much money she spent on braids. Can we spend more than $29? No. Can we spend less than $29? Sure. Can you spend equal to $29? Of course you can. So let's talk about how we get charged for these braids. We are going to get charged a flat rate of $4. So we're getting charged $4 no matter what, and then 75 cents per braid. So if we bought 1 braid, it'd be 75 cents times 1. If we bought 2 braids, it'd be 75 cents times 2. If we got 3 braids, it'd be 75 cents times 3, but we got X braids, so it's 75 cents times X. We just put them next to each other. We don't need parentheses because in math, this is the coefficient, the number in front of the variable that's being multiplied. So again, this amount here could be equal to $29 because that's how much money we have to spend. It can't be greater than because we don't have more than $29, but it can be less than. So we know that 4 plus 0.75x could be less than or equal to 29. Let's go ahead and solve the problem together. First, to isolate our variable, I'm going to subtract 4 on both sides. I have 0.75x is less than or equal to 25. Good job. Now we're going to divide both sides by 0.75. Go ahead, use your calculator for that. When you do that, you end up with x being less than or equal to 33 1/3. Okay, so how many braids can she get? Caitlin can get, well, we're talking about braids. Can you get 1/3 of a braid? Are they really just going to braid that much? No, they are not. So she can get, at most, 33 braids. Excellent. Let's take a quick break while we switch to the next video.